Okay, let's take a look at factoring quadratics, a quick review. A quadratic is a second degree polynomial in the form ax squared plus bx plus c, where the x's are variables and our a, b, and c are real number coefficients. So that's the standard form. And we're going to take a look at how to factor this in quadratics three different ways. First, we're going to look at factoring in this standard form, ax squared plus bx plus c, where a equals 1. Then we're going to look at factoring a quadratic binomial, where we're missing the constant, so we just have ax squared plus bx. And then we're going to look at a third method, factoring another binomial, where it's ax squared minus c, where a and c are both perfect squares. Okay, so let's take a look at factoring our standard form. So factor ax squared plus bx plus c, where a equals 1. And I'm going to use an example. I'm going to use x squared minus 7x plus 12 as my example as we go through here. So what we're looking for when our a value is 1, remember if we have no coefficient in front of our variable, we assume a 1. So a is 1, so it meets our criteria. Our b is negative 7, and our c is 12. And what we're looking for are the factors of c that add up to b. So let's find our factors of c first. So we have 1 and 12, 2 and 6, 3 and 4. Well, Houston, we got a problem because none of those factors add up to negative 7. We've got 7, we've got 8, and we've got 13. So what we have to look at is the fact that b is a negative 7 and c is a positive 12. So if the b is negative and c is positive, then both the factors are going to be negative. So let's make all these negative. And now we have a negative 7. So negative 3 plus negative 4 does equal negative 7. Those are factors. And all we have to do is write them. So we've got x squared minus 7x plus 12, and that factors into x minus 3, x minus 4. Cool? I think it is. So let's take a look at another example. Okay, so this time we're going to look at x squared minus 4x minus 12. So we're going to use our same factors again. This time we still have an a of 1, a b is negative 4, and our c is negative 12. We got 1 and 12, 2 and 6, 3 and 4. And again, we've got a problem. Now, if the b is negative and the c is negative, then the larger factor takes the sign of b. So our larger factor has to be negative in this case. And this actually works for if b is positive. If the c is negative, then the larger factor takes the sign of b. So we got a negative 12, so a negative 4. So we mark those, and then we can see that 2 and negative 6 add up to negative 4. So our factors here in this case are x plus 2, x minus 6. There we go. So factors of c that sum to b. All right, let's take a look at our second method, where we're going to factor a quadratic in the form of ax squared plus bx. So we have no constant. We have no c. In this case, we're going to factor out the greatest common factor, also known as the GCF. Here I'm going to use an example, 6x squared plus 3x. Now, greatest common factor, we have an x and an x squared, so we can factor out an x. And then we can factor out the greatest common factor of 6 and 3, which is going to be 3. And then I'm going to divide both of those by 3x, and I get 6x squared divided by 3x, 2x. 3x divided by 3x plus 1. And there we go. We have two linear factors of our quadratic, and we're good to go. Let's take a look at another example. I've got negative 12x squared plus 24x. Now, when we have a negative coefficient, we want to bring out our negative leading coefficient. We want to factor out that negative. So in this case, we're going to factor out a negative 12. So we have negative 12x. So we end up with x minus 2 when we divide it out. All right, so that's ax squared plus bx. Now, our third form that we're going to look at factoring is in the form ax squared minus c, where a and c are perfect squares. So let's take a look at this. So that's going to be in the form of 1, there's my minus. 1 is a perfect square. Call this a difference of squares. So we have 4x squared minus 36. So 4 is a perfect square, 36 is a perfect square. We can think of this as 2 squared and 6 squared. So our 4x squared minus 36 will factor into 2x plus 6, 2x minus 6. Look at another one. We have x squared minus 64. Remember, we can assume our 1, and a 1 is a perfect square. So the square roots of 64 are 8 and 8. So it's x plus 8, x minus 8. And then if we do one more, x squared minus 256. Again, x plus 16, x minus 16. Okay, so in summation, when we're factoring our quadratics, when we have a standard form, ax squared plus bx plus c, we're going to find the factors of c that add to b. And this is when a equals 1. Next, if we have ax squared plus bx, then we're going to factor out the greatest common factor from each of them. And then finally, when we have ax squared minus c, where a and c are perfect squares, then our factors are going to be the square root of a times x plus c, the square root of c, times the square root of ax minus the square root of c.